Children, so in today's class we will see the new topic that is called allotropes of carbon. So before that, first you should know what is allotropy. Allotropy is a phenomenon by which an element can exist in two or more physical forms. So some elements have the tendency to exist in two or more physical form, and this phenomenon is called as what? Allotropy. Okay, whereas the two or more physical forms in which an element exists are called as allotropes. Okay, so allotropy is a phenomenon where allotrope is two or more physical forms in which an element exists. Okay, so you could see there are various elements in our surroundings which shows allotropy, or which have the allotrope, which have two or more physical forms, and the examples of those elements are carbon, okay, then phosphorus, oxygen, sulfur, etc. Okay, so these are the elements which have the tendency to exist in two or more different forms. That means they all have the allotropes. They show the phenomenon called as allotropy. So basically in this chapter you have to study about the allotropes of carbon, two or more different physical forms of carbon. Okay, so we will see the allotropes of carbon. Before that, I would like to tell you that since these allotropes have two or more different forms, the allotrope of any element which have two or more different forms, so obviously they have different, all the allotropes have different physical properties because they have different physical forms, but all these allotropes of the same element will show the same chemical properties. Okay, because of being made by same chemical or a same element. Okay, so we will just see the allotropes of carbon. Okay, so there are basically three allotropes of carbon. Okay, the first one is diamond, second is graphite, and the third physical form or allotrope of carbon is fullerene. Especially you have C60, okay, which is called as Buckminster fullerene. Okay, so these three are the three different forms of carbon. Carbon exists in these three different physical forms, and these three physical forms are called allotropes. So diamond is one of the allotropes of carbon, then graphite and fullerenes. Okay, so as carbon also occur in our environment in combined state also. Okay, if you see carbon in combined state, they are in the form of carbon dioxide in our atmosphere. They are also found in combined state in the form of salts of carbonates, okay, like calcium carbonates, that is marble, chalk, है ना, or in form of calcium oxide, that is lime. Then they are also found in the form of wood, charcoal, है ना, wood, charcoal. Then you have wool, cotton, ठीक है. They are also found in the form of organic compounds. Organic compounds also, like all the biochemicals like fats, vitamins, then carbohydrates. ठीक है. So carbon is also found to be present in combined state in these forms. Okay. So basically we have to see here the three physical forms, that is diamond, graphite and fullerenes. Individually their structure, properties and physical properties, etc. Okay. So one by one we will see all the allotropes of carbon. So first we will see the properties and the structure of diamond, which is one of the allotropes of carbon. Okay. So you know that diamond is the hardest substance. You would be knowing well about diamond. Diamond is the hardest substance. Okay. And how the synthesis of diamond take place. Okay. So diamond is found in earth crust only. So naturally it is found in our environment in a very small amount. Abundance is very less, and you can also synthesize it in the lab also. So how it can be synthesized? And this can be synthesized by subjecting carbon atoms, okay, subjecting the pure carbon, you can say, subjecting pure carbon to a very high pressure. Okay, to a very high pressure and high temperature, extremely high pressure and temperature. If you see the pressure, you have to apply almost about 50,000 to 60,000 atmosphere pressure to the pure carbon, along with very high temperature, okay, of about 1873 Kelvin. ठीक है, to this pure carbon, and you can get the carbon, you can see the carbon getting converted into the diamond. But this diamond, whatever you get after synthesis, that is called a synthetic diamond, and it is, you cannot differentiate actually the artificial or the synthetic diamond with the pure diamond. Okay. So when the pure carbon is made to when the pure carbon is subjected to very high pressure and very high temperature, then you can get the carbon getting converted into the diamond. But this diamond is called as synthetic diamond, as it has been synthesized in the labs. Okay. So now we will see the synthesis, or after synthesis we will see the structure of diamond. So I just told you about the synthesis, how you can just synthesize the diamond, that is artificial diamond. Okay. So we will see now the structure of diamond. If you see the structure of diamond, it is something like that, where one carbon atom, each carbon atom in diamond, you will see it is attached to 4 other carbon atoms, like that. Okay. Each carbon atom is attached to 4 other carbon atoms. Now this, where you can see this, here you can see each carbon atom is attached to 4 other carbon atoms by single covalent bond. As you can see, the bond between each carbon atoms are covalent bond. And if you see the bond length between each carbon atoms, between the carbon atoms, the bond length is about 1.54 angstrom. Okay. Angstrom is the unit to measure the bond length. Okay. It is 1.54 angstrom. You can also represent bond length in picometer also. Okay. or angstrom is also an unit to represent the bond length of between any atoms. Okay, so between two carbon atoms the bond length is about 1.54 angstrom. So as I told you, each carbon atom is attached to 4 other carbon atoms. Okay, like this. Okay, like this. Okay, so here also, okay, these are attached. Okay, okay, so as you can see in diamond, each carbon atom is attached to 4 other carbon atoms by single covalent bond of bond length 1.54 angstrom. Okay, so bond is about 1.54 angstrom long, and surrounding 4, if you take one structure where the carbon atom is bonded to 4 other carbon atoms, so these 4 carbon atoms are at the corners making a structure called as tetrahedron, making the structure called as tetrahedron. So they show the geometry of regular tetrahedron. They have the tetrahedral structure, as you can see. Okay, so each carbon atom will show that, as you can see here also. So this structure is what? It is the regular tetrahedron structure. Okay, so if it is asked in the exam that what is the geometry of the carbon atoms in diamond, you will see that you will tell it is tetrahedral. Okay, and the structure is the regular tetrahedron structure. Understood? Now what is the bond angle? This is called as bond angle. What is the bond angle between the two covalent bond or between the two carbon atoms? Okay, so what is the bond length between the two covalent bond in the diamond? It is about 109.28 degrees, or you can say 109 degrees 21 minutes. Okay, so you should also know in the regular tetrahedron or in the regular tetrahedral structure, the bond angle will be always 109.28 degrees. Understood? So that's how the structure of diamond is. Okay, so I'll repeat, each carbon is attached to 4 other carbon atoms by single covalent bond and having the bond length 1.54 angstrom. Okay, now surrounding carbon atoms are at the corner, giving the structure a regular tetrahedron. Okay, a regular tetrahedron like this. Okay, and the angle between the two adjacent covalent bond is 109.28 degrees. Okay, so due to this tetrahedral arrangement of carbon atom, diamond shows the rigid structure, a rigid 3-dimensional network structure. Okay, so it is called to show the rigid 3-dimensional Okay, three-dimensional network of carbon. ठीक है, this shows three-dimensional network structure of carbon. Understood? As you can see, carbon is fulfilling all its tetravalency. So you can say that here no free electrons are present in carbon atom. In each carbon atom, it is bonded to 4 other carbon atoms through covalent bond. So there is no free electrons present in any carbon atoms. That's why it does not show any conduction. That's why it is called as the non-conductor of heat and electricity. Understood? It is one of the properties of diamond that it shows the non-conduction of heat and electricity. So this is about the structure of the diamond. Okay, now what are the physical properties of diamond? We'll see some physical properties of diamond. So due to its high refractive index of about 2.5, diamond undergoes the refraction and reflection and are transparent in nature. Okay, you should be knowing the refractive index. Refractive index is the ratio of velocity of light in vacuum to its velocity in a specified medium. So since its optical density, diamond optical density is higher, its refractive index is also higher, that is of 2.5 value. Okay, it is a transparent substance. Okay, and it is also the hardest substance. It is famous for its hardness. Why? Because if you see the structure of diamond, it has the rigid three-dimensional network structure, which makes the diamond a hardest substance. Understood? Okay, now next is it has a very high melting point. If you see the melting point, it is about 3930 degree Celsius almost. Okay, as I told you, it has a high density. It also shows what? Very high density. Density is of 3.51 gram per cm3. Okay, 3.51 gram per cubic centimeter. So you know that diamond has many applications. It is used in making jewelries. It is used in decorating the jewelries. And since it is a hardest substance, so it is also used in cutting the hard materials like marbles, granite, etc. And sharp edged diamond is also used to remove the cataract from eyes. You would be knowing the disease cataract in eyes. So to remove cataract in eyes, sharp edged diamond is used. So it has the medical applications also. Okay, it is also used as abrasive, that is used in shaping, grinding, or in cleaning the hard substances. Okay, so these all applications are with respect to its hardness. Okay, because it is a hardest substance, it has a wide applications. Okay, so now the second allotrope of carbon is what? Graphite. Okay, so we will quickly go to the structure of graphite. So as you can see, the graphite actually is made by the layers and layers of carbon atom, many layers of carbon atoms. So I have made here the one layer of carbon atom, where you can see the in graphite each carbon atom, okay, each carbon atom is bonded to three other carbon atoms in the same plane. So this is the plane in which you could see each carbon atom is bonded to three other carbon atoms, as you can see. Okay, in the same plane to form a hexagonal ring. This is what a hexagonal ring, as you can see. This is one hexagonal ring, this is one hexagonal ring, and these hexagonal rings are not isolated, ये अलग अलग नहीं है, but they are like the fused rings. ठीक है, hexagonal rings. ठीक है, as you can see, it has 6 corners, no, 1 2 3 4 5 6, and in each corner of the hexagon you could see the carbon, and each carbon is attached to 3 other carbon atoms covalently bonded to each other. Okay, and each hexagonal ring is fused with the other hexagonal ring. Fused means what? They are combined with the other hexagonal ring. They are not isolated. अलग अलग hexagonal rings नहीं है, हेक्सेन नहीं है. एक हेक्सागोनल रिंग दूसरे हेक्सागोनल के साथ क्या हो गया? फ्यूज हो गया है, कंबाइन हो गया है. ठीक है, सो दिस इज वन लेयर. ठीक है, आई हैव शोन यू द वन लेयर. ठीक है, like that you have many layers of this hexagonal ring, giving you the hexagonal array. ठीक है, that's how the structure of graphite is. So I'll just show you the other layer also. ठीक है, so it is a two-dimensional sheets actually, like structure consisting of number of hexagonal rings fused to each other. ठीक है, so I'll just show you the other layer. Okay, like this. They are also arranged something like that. Okay, here each corner of hexagon consists of what? One carbon atom, like that. Okay, so here you can see each carbon atom is bonded to 3 other carbon atoms. Okay, so how these rings are attached with each other? One ring is the rings are one above the other. So how they are arranged? They are actually connected. The rings are connected, the layers are connected with each other by a very weak force. See, like that they are connected. Okay, okay, as you can see. So these rings are one above the hexagonal rings. The layers of hexagonal rings are attached to one another with a very weak force, as I have shown you in green color. These weak forces are called as van der Waals forces. Okay, so layer by layer you can see you have many layers of hexagonal array, and they are combined, or they are attached with a very weak force, that is van der Waals force, which slides over each other. As you can see, when you can see the tip of pencil is made up of graphite only, and when you start writing with the pencil, that is the graphite one, you could see the you can see the layers breaks and it falls on the paper, and then you are able to write it comfortably, because the layers are very attached very with a very weak force. That's why when you press the graphite, the layers which are attached with each other with a very weak force, they break and they fall on the paper, which make you to write on the paper. Understood? So this is about the structure of graphite, okay, where the sheets of layer are held together by a very weak force, that is called van der Waals force of attraction. Okay, now the distance between the two successive layers, okay, is about 340 picometer, or you can say it is 3.40 angstrom. Understood? So the distance between, distance means this distance, okay, the distance between the two successive layers, this layer and this layer, is about 340 picometer, or 3.40 angstrom. So that's how you can see the structure of graphite. One more thing here each carbon atom is bonded to 3 other carbon atoms, and you could see there are 3 single and double, alternate single and double bond present in each hexagon, okay, in order to give the stability of each carbon atom, in order to make each carbon atom stable. So here you can see the 3 valence electrons of carbon are used for making the covalent bond with the other carbon atom, and 1 free electron is there at each carbon atom, which is delocalized in the ring only. They are not localized, but they keep on moving, okay, like this. They keep on moving like this. Okay? From each carbon atom, you could see 1 free electrons are present, which are delocalized in the ring. Okay? That's why graphite acts as a conductor. Why? Because in graphite, each carbon atom in hexagon or in a hexagonal ring are delocalized, and these free electrons are responsible for conducting the electricity. Okay, so graphite, though it is a non-metal, it shows the conductivity of electricity due to the presence of 1 valence electron on each carbon atom in the ring. Understood? We'll see some physical properties of graphite. Okay, so first is it is an opaque grayish black substance. Okay, graphite is an opaque grayish black substance. Second, it is also famous for its softness and slippery nature. Why? Because the layers, as we have just now seen the structure of graphite, where we have seen the layers or the sheets of carbon atoms are held together by a very weak force. Okay, here the layers are one above the other, layers of the hexagonal rings are one above the other, and these hexagonal layers they are attached, okay, by a very weak van der Waals forces of attraction. So one layer can slide over the other, making the graphite a very soft material. Okay, now it has high melting point, and melting point is about 1800 Kelvin. Okay, so it can withstand high temperature because of its high melting point. It melts at very high temperature. Okay, so it can withstand very high temperature. Now it has low density. So density is also it ranges from 2 to 2.2 gram per cm cube. Okay, so why the density is low in graphite? Again, you can see here in the structure there is wide space in the between the layers of graphite. So because of the wide spaces, or so many spaces are there in the structure of graphite, which makes the graphite a lower density material. Understood? Okay. Now it acts as a conductor of heat and electricity. So it is a good conductor of heat and electricity. The reason I have already discussed, because of each carbon atom in the hexagonal ring has one free electrons. As you know that the carbon atom has 4 valence electron. It shows tetravalency and it can form 4 covalent bond as that of diamond. But in graphite only carbon atom is bonded to 3 other carbon atom, means 3 valence electrons are used and 1 electron which is free, which is not bonded. So each carbon as you can see is bonded to 3 other carbon atom with a covalent bond, and the fourth electron, valence electron of carbon is free. So it is there in each carbon atom. It's like that only. So here the electrons are delocalized in the ring. So because of the free electrons, graphite acts as the good conductor of heat and electricity. Understood? So in the question, if it is asked why it acts as conductor, so you will write due to the presence of free electrons, graphite conduct electricity and heat. Okay, and it is called as a good conductor of electricity. Understood? So there are also wide uses of wide application of graphite. Okay, since it is soft and slippery because of the layers being attached with a very weak force, that is van der Waals force, it is soft and slippery. So it is used for making black core of pencil called pencil lead. So pencil lead is basically made up of graphite, and when you press it, one layer of graphite slides over the other. Okay, it falls on the paper, which enables us to write on the paper. So it is used in the black core of pencil called as the pencil lead. Okay, other use of graphite, it is also used as the carbon electrode in dry cells. In dry cells you would have been studied about the electrode. So electrode there is made up of carbon electrode, and that is nothing but the graphite electrode. So it is also used as electrode in dry cell. Okay, because it is a soft material, its powder can be used as the lubricant. Okay, lubricant means what? Which is used for lubricating the machine part, usually made up of iron. Okay, metal. So the metal part of machine can be lubricated by using graphite as the lubricant. Okay, and also due to its high melting point, graphite is used for lubricating machine part used at a very high temperature. Understood? So these are some of the applications of graphite, which is one of the electrodes of carbon.